Good day. We will present Network Security Infrastructure, Chapter 3. Network security infrastructure is vital for protecting data integrity, confidentiality, and availability amid evolving cyber threats. Technologies like firewall, encryption, and multi-factor authentication are essential components of detecting, preventing, and responding to malicious activities, ensuring security's network operation. Learning outcome. At the end of the unit, the student should be able to different network security and network security infrastructure, compared firewalls, and intrusion detection prevention system, and make recommendation for deployment to monitor and control network traffic. Design network segmentation and virtualization strategies to create separate security zone and control lateral movement. Evaluate the use of deception technologies like honeypots and honeynets to detect malicious activities and gather threat intelligence. Develop requirements for security information and event management (CM) solution to aggregate, correlate, and analyze log to identify security incidents.
For the learning content, let's first discuss the network security infrastructure. Network security protects your computer and the information it contains from unauthorized access. A variety of means may implement network security. A collection of tools, policies, and procedures designed to protect your computer and its information from unauthorized access. Network security refers to the measures taken to protect a computer networks and the data transmitted over it from unauthorized access, misuse, or modification. It involves both hardware and software technologies, as well as policies and procedures designed to defend against threats and vulnerability. For an example, encrypting data sent over the Wi-Fi network using a password ensures that only authorized users can access the network and prevent overstrapping by attackers. Next is network infrastructure security. It's ideal for companies' IT infrastructures, protecting the hidden networking infrastructure by enforcing preventive security measures to avoid unauthorized access, alteration, theft, or deletion of data or resources. Network infrastructure security involves safeguarding the physical and virtual components of network, such as routers, switches, servers, and cables from threats and vulnerabilities. It includes measures like access control, encryption, and monitoring to ensure integrity, confidentiality, availability of network resources. For example, securing network infrastructure may involve implementing a strong authentication mechanism to restrict access to critical network devices, such as routers and switches, only to authorized administrators.
Firewall. A firewall is a network security device that observes and filters incoming and outgoing network traffic, adhering to the security policies defined by an organization. The types of firewalls. First is a packet filtering. A packet filtering firewall controls data flows to and from a network. The example of packet filtering firewalls is the router configured to permit HTTP traffic through port 80 but block FTP traffic through port 21. The second is a packet free proxy service firewall. This type of firewalls protects the network by the filtering message at the application layer. This packet free proxy service firewalls is essentially a go-between from every connection on a network. The fourth is next generation generation deep packet inspection firewalls that adds application-level inspection, intrusion prevention, and information from the outside the firewalls to go beyond the port or protocol inspection and blocking. This next generation firewall is a part of the third generation of firewalls technology, combining a conventional firewall's others network device filtering function such as an application firewalls using inline deep packet inspection and intrusion prevention system.
Does a firewall work? Firewall allowing good traffic. Internet, good traffic, firewall, private network. The firewall blocks malicious traffic from entering the private network, thereby protecting the user network from being susceptible to a cyber attack.
So what is intrusion detection? An intrusion detection system, or IDS, is a vigilant application or device that proactively screen, monitor, and analyze a network against malicious threats. Types of intrusion detection system. Needs. Strategically placed within an organizational internet network infrastructure to actively monitor and identify any malicious or suspicious traffic originating from devices connected to the network. HIDS. Safeguard all devices that connect to both internet and the organizational internal network. How do intrusion detection system work? Signature-based detection. The IDS examines all packets traversing an organization network and matches them against a database of known attack signature through a string comparison. Anomaly-based detection. The IDS compare definition of what is deemed normal with recorded events to spot deviation in network activity. Stateful protocol analysis. The IDS analysis observe events within predefined profiles or protocol activity that are safe or benign. IDS versus firewall. An IDS passively observes network activity, alerting incident responders or security operation center analysis to potential threats. However, it does not offer protection for endpoints or network beyond incident response. In contrast, a firewall actively monitors and blocks threats to prevent incident. It acts as a barrier, selectively allowing or blocking network traffic based on pre-configured rules. Types of IDPS. First, network-based intrusion prevention system. Monitor entire network or network segments. 4. Malicious traffic filtering. Firewall controls data flow to and from a network. Second, wireless intrusion prevention system. Monitor wireless network by analyzing wireless network-specific protocols. Third, network behavior analysis. Identify threats by checking for unusual traffic patterns. Fourth, host-based intrusion prevention system. Deep packet inspection firewall that adds application-level inspection, intrusion prevention, and information from outside the firewall to go beyond port, protocol inspection, and blocking. Monitoring and control network traffic tips. Tip 1. Choose the right data sources with two main data. Number 1 is flow data, second is packet data. Tip 2. Pick the correct points on the network to monitor. Tip 3. Sometimes real-time data is not enough. Tip 4. Associate the data with usernames. Tip 5. Check the flow and packets payloads for suspicious content.
Network segmentation and virtualization. Network segmentation is a network security technique that divides a network into smaller distinct sub-networks. Network virtualization is the provisioning of network and security services independent of the physical infrastructure. Security zone.
A security zone is a part of the network to define specific policies and protocols to keep the entire network threat-free. Lateral movements refer to a group of methods cybercriminals use to explore an infected network to find vulnerabilities, escalate access privileges, and reach their ultimate target. In network virtualization, we have VLANs, VPNs, and SDNs. And in network segmentation, we have firewalls, routers, and switches.
So let's talk about the honeypots and honeynets. What is honeypot? A honeypot is a single service or computer on a network that is configured to act as a decoy, attracting and trapping would-be attackers. What is honeynet? A honeynet, on the other hand, is a network of honeypots that are used to lure in attackers and study their activities across multiple honeypots. Honeypots are classified according to their aims and levels of interaction. If you look at the aims of honeypots, you can see there are two designs. The first design is the production honeypot. And this design, it deployed in production alongside servers. This class acts as the front-end trap. The second one is the research honeypot. This class is tied explicitly to researchers and is used for analyzing hacker attacks and guiding on techniques to prevent these attacks. In this, they educate you by containing data that you can trace back when stolen. So, how do honeypots work? So, here is how honeypots work. And here is a breakdown of the available models of honeypots. First is the email traps. In this email traps, it is an alternatively known as the spam traps. This type places fake email addresses in a hidden location where only automated address harvesters can find them. Second is the decoy database. In this method, you set up a database to monitor software vulnerabilities and attacks, exploiting insecure architectures, SQL injections, other service exploitations, and abuse of privilege. Third one is the spider honeypot. This class traps web crawlers or the spiders by creating crawler-only accessible websites and web pages. And the fourth one is the malware honeypots. This model mimics software programs and application interfaces, AMIs, to invoke malware attacks.
How do honeynets work? Honeynets are decoy networks containing collections of honeypots in a highly monitored network. Honeynets act as a digital traps for cyber attackers. They look like real networks but are kept separate and watched closely. When attackers engage with the honeynet, what they do is recorded and studied to make defenses stronger. Why do you need honeynets? Honeynets come as honeypots with advanced value-added features. They provide a more comprehensive way to trap attackers and gather valuable insights into their methods, divert intruders, and collect a detailed analysis of their behavior and operation models or patterns, helping us understand their tricks and patterns. Terminate infected connections to shut down harmful attackers, stopping them from causing damage. As a database that stores large logs of login sessions from which you can view attackers' intentions with your network or its data. The difference between honeypots and honeynets. A honeypot is deployed on a single device, while the honeynet needs multiple devices and virtual systems, meaning honeypot as a security setup on one computer, like a decoy to attract attackers, but a honeynet is like a bigger security system with many computers and virtual setups spread out. Honeypots have a low logging capacity while honeynets have high, meaning honeypots can only record a limited amount of information about attacker activity, while honeynets can store a much larger volume of data. The hardware capacity needed for the honeypot is low and moderate, while that of the honeynet is high and needs multiple devices. Honeynets rely on a series of elements that are work together seamlessly. HoneyNets rely on a series of elements that work together seamlessly. Here are the constituent parts. HoneyNets are a series of 1. Honeypots specially designed computer systems that trap hackers, other times deployed for research and occasionally as decoys that lure hackers from valuable resources. Sometimes they're used for research and other times they act as decoys to distract hackers from important resources. Second, applications and services. You must convince the hacker that they are breaking into environment and worthwhile. These are software programs and tools used to make hackers believe they're infiltrating or a real and a valuable environment worth their effort. Third, no authorized user or activity. A true HoneyNet only traps hackers. And lastly, honey walls. Here you are aiming to study an attack.
Security Information and Event Management or CIEM. CIEM is a combination of two other acronyms describing common cybersecurity methodologies. Security Information Management or CIM. Security Event Management or CEM. CIM is the process of collecting and monitoring. CEM, this class traps web crawlers or spiders by creating crawlers-only accessible website and web page. How does CIM work? Collecting, analyzing, and correlation. So, some organization may still be wondering, what does CIEM do and how does it work? CIEM technology gathers security-related information from server and user device, network equipment, and application, as well as security device. The aggregation and analysis of data gathered throughout the network enable security team to see the big pictures, identify breaches or incident in the early stage, and response before the damage is done. Type of security management: information security management, network security management, and cybersecurity management. Information security management, implementing security best practices and standard design to mitigate threats. Network security management, a vital component of a network management strategy. Cybersecurity management, more general approach to protecting an organization and its IT asset against cyber threats. CIEM features and capabilities. First, data aggregation, correlation, dashboard, alerting, and automation. Data aggregation, data is collected and monitored from applications, networks, servers, and databases. It also helps organizations to achieve specific business objective. Correlation, typically a part of SEM in a CIEM tool. Correlation refers to the tool finding similar attributes between different events. Expresses the extent to which two variables are linearly related to other and they change together at a constant rate. Dashboard, data is collected and aggregated from applications, databases, and networks and servers. Alerting, if a security incident is detected, CIEM tools can notify users. Automation, so some CIEM softwares might also include automated functions. It uses of technology to perform tasks with reduced human assistance.